Episode 2: A slow journey through our solar system. Welcome. Settle in, slowly, with no rush at all. Let the weight of the day find its way out of your shoulders, your jaw, the small muscles around your eyes. There is nothing to do now. Nothing to remember, nothing to plan, nothing to keep hold of. The room around you is steady, the bed beneath you is patient, and the night is long enough to hold whatever you bring to it. Tonight, we are going to take a slow journey. Not the kind that asks anything of you. Not the kind that needs your attention every moment. This is the gentlest sort of travel, the sort where you do not so much arrive as drift, and where the landscape moves quietly past whether you are watching or not. We are going to walk, in a manner of speaking, from the warm center of our solar system all the way out to its dim and quiet edge. From the slow beating heart of the sun, outward through worlds of stone and worlds of cloud and worlds of ice, past the small wanderers between them, past the great storm of Jupiter and the rings of Saturn, past the pale tilt of Uranus and the windy dark of Neptune, into the scattered belt of frozen things, and finally to Pluto, sitting alone in the cold like a small lit lamp on the porch of the solar system. Perhaps you will be awake for some of it. Perhaps you will not. That is, in fact, the point. The journey does not require you. It is happening already, all of it, right now, in the spaces above your roof and far beyond. The sun is burning. The planets are turning. The cold worlds at the edge are doing whatever cold worlds do when nobody is looking. You are not needed for any of it. You can simply be carried. If your eyes are open, let them rest where they like. If they are closed, let them stay closed. There is no need to follow along. The words will keep moving even when you stop listening to them, and that is allowed, and that is good. Anything you miss tonight you have not really missed. The sky has been there for a very long time. It will be there tomorrow. Notice, for a moment, your breath. Not in a deliberate way. Not as a task. Just notice that it is happening on its own, the way the planets are turning on their own, the way the sun is shining on its own. You do not have to do anything. The breath comes in, the breath goes out, and your body keeps the long quiet rhythm without asking your permission. It is one of the kinder things about being alive. Most of it is taken care of. We will begin at the sun. Not because it is the start of anything, exactly, but because everything in our solar neighborhood is held in its slow and steady pull. The sun is the warm hearth around which everything else is gathered, like chairs drawn up to a fireplace in a still old room. Every planet we visit tonight is, in its own way, leaning toward that fire, or moving carefully around it, kept in place by a force we cannot see. And then we will move outward, slowly. Mercury first, scarred and small, very near the heat. Venus next, hidden under thick pale cloud. Earth, your own home, viewed from a distance you will never quite manage in person. Mars after that, dust red and thin-aired and quiet. Then the long careful drift through the asteroid belt, where the stones tumble in silent slow motion. Then Jupiter, vast as a small star, banded with storm. Then Saturn, ringed and luminous. Then Uranus, lying on its side, blue and patient. Then Neptune, far and windy and dark. Then the wide cold ring of the Kuiper belt, where small worlds float in the distance. And at last, Pluto. Small, far away, sun-touched only barely, like a candle seen across a long room. There is no quiz at the end. There are no questions. You are not required to remember any of this. The names are pleasant to say in the dark, and that is enough. The pictures will form however they want to in your mind, and then they will gently fall apart, and that is enough too. Your body knows how to do this part. It knows how to soften. It knows how to sink. It knows how to set down the 100 small things it has been holding all day and let them rest somewhere outside the bed for a little while. If something tries to come back up, a worry, a chore, a sentence you did not finish, let it pass through, and let it keep going. There is plenty of room out in the solar system for unfinished sentences. So, settle. Close your eyes, if they are not closed already. Let your shoulders go heavy, then your arms, then your hands. The journey is going to be slow. The journey is going to be quiet. The journey is going to take care of itself. We will start at the Sun. Chapter 1: The Sun. Imagine you are very far above the world. Higher than any aeroplane has ever flown, higher than any cloud has ever drifted, higher than the place where the sky turns from blue to the deep blue of nothing at all. From here, the Earth is small and round, and you can see almost the whole of it. And yet, somehow, far across the dark, the Sun is still larger. Not larger in the picture, perhaps, but larger in the way it presses on everything. You can feel it the way you feel a warm room when you have just come in from a cold hallway. Even out here, it is the source of all the warmth. The Sun is a star. That is the first thing to say, in the way one says it gently. The same word, star, that you might use for the small silver pricks of light when you look up from a dark garden at night. Those tiny distant points are suns. Other suns. Many of them larger than ours, many smaller. Ours just happens to be ours. Ours just happens to be near. Ours is the one we have, the one our planet has spent its whole life leaning toward, the one whose light fell on the first leaf ever to unfold, and whose light still falls, this very minute, on every windowsill on the planet. It is not large, as stars go. It is not small, either. It is what astronomers call an average yellow star, although when you look at it directly, and you should not, of course, it does not appear yellow, exactly. It appears like a furnace door that has been left open. It appears like something that should not be looked at and cannot quite be looked at. Even from 93 million miles away, even after its light has traveled through 8 minutes of empty space to reach you, you cannot rest your eyes on it. That is, perhaps, the first lesson of the Sun. It is so generous with its light that you must look away. Let us approach it slowly, as one approaches a fire on a cold night. Not too close. Just close enough to feel it. If you could shrink the Sun down to the size of a small lamp on a bedside table, the Earth would be a grain of pepper rolling somewhere on the far side of a quiet room. It is that much bigger. About 109 Earths could be laid in a line across the face of the Sun. About 1 1/3 million Earths could be packed inside it if you found a way to do that and were willing to be patient. These are not really numbers your mind needs to hold tonight. Let them slide past like leaves on a stream. The point is only this. The Sun is enormous in a way that is gentle to think about and impossible to truly imagine. It is also, in its way, very old. Old in a way that makes a human life feel like one quiet breath. The Sun has been shining for about 4,500 million years. It will go on shining for about another 5,000 million. It is, at this moment, somewhere in its calm middle age, like an old friend halfway through a very long story, neither in any hurry to finish nor at any risk of stopping. There is something quietly comforting about that. The Sun is not going anywhere tonight. What is it made of, this calm middle-aged star? Mostly two things, and both of them simple. Hydrogen, the lightest, smallest thing in the universe. And helium, only a little heavier. If you wanted to make a sun in a kitchen, those would be your main ingredients, although you would not, in any case, have a kitchen large enough or a stove patient enough. The sun is a great bright cloud of these two gases, held together by its own enormous weight, pressing down upon itself until the very center is hotter than anything that can be imagined. At that center, the core, as it is called, the temperature is somewhere around 15 million degrees. There is no word for that kind of warmth in the language people use to talk about kettles and radiators. It is not warmth, really. It is the temperature at which things stop being themselves. Where atoms forget who they are. Where hydrogen, pressed so tightly together by so much weight, gives up its separateness and becomes helium. Becomes, in the very act of becoming, light. That is what is happening, all the time, in the heart of the sun. Hydrogen is becoming helium. Not all at once, but constantly, quietly, in numbers so vast they would be silly to write down. Every second, the sun turns about 600 million tons of hydrogen into helium. Every second. A million of those tons disappear entirely, transformed into pure light and pure warmth. The sun is, in a sense, a great calm furnace that is burning itself away, very slowly, into illumination. And here is the gentle strange thing. The light you can feel on your face on a summer afternoon, that light did not come from the surface of the sun the day before. It did not even come from the surface a year before. The light that reaches you began, in fact, deep in the core, perhaps 100,000 years ago. When no city you have heard of existed. When no language you speak had been invented. When the first humans were only just beginning to wonder about the sky. A particle of light born in the core of the sun must travel outward through a great dense fog of itself, bumping, scattering, being absorbed and released again, before it finally finds the surface and escapes into the dark. That can take 10,000 years. It can take 100,000. Only the last 8 minutes of its journey are spent crossing empty space to reach the Earth. So when you have stood in sunlight, you have stood in something patient. Something that has been on its way to you for longer than your kind has been alive. That, too, is the sun. If you could pull back from it now and watch from a safe distance, if you could borrow the eyes of a spacecraft hovering at a respectful remove, you would see that the sun is not a smooth glowing ball at all. Its surface, what astronomers call the photosphere, is more like a vast restless soup, bubbling endlessly. The bubbles are huge. Each one of them, if you could lift it up and set it down on a country, would be larger than the country. They rise, they cool just slightly, they sink back in. The whole face of the sun is gently boiling, all of the time, in a slow soft motion that has been called granulation, as if the sun were made of grain. Sometimes, the sun does more than simmer. Sometimes, great looping ribbons of brighter material rise off its surface and arc back down again, taller than worlds. These are called prominences. They unfurl quietly, hang in space for hours or days, and then settle. Sometimes there are darker patches where the magnetic field has tangled itself into knots. These are sunspots. They look small from where we are, but each one would swallow the Earth easily. They drift slowly across the face of the sun, and they fade, and new ones rise. The whole star is breathing in its own slow way, just as you are breathing in yours. Beyond the bright surface, beyond even the prominences, there is something stranger still. A pale wispy crown that surrounds the sun like a great soft halo. It is called the corona. You cannot usually see it, because the surface beneath it is so much brighter. Only during a total eclipse, when the moon slides perfectly across the face of the sun, does the corona become visible. It looks then like a feathered silver wreath, drifting slowly outward in long streamers. The corona is the sun, still, but a thinner, ghostly version of it, reaching out into space. And it does not stop there. The corona slowly fades and stretches outward into a steady, gentle stream of particles called the solar wind. The solar wind blows in every direction at once, away from the sun, filling the whole of the solar system. It is so faint you could never feel it on your face. It is so vast it touches every world we will visit tonight. We are all of us, every planet, every moon, every drifting stone, sitting inside the breath of the sun. Think, too, of what the sun does for you that you never feel. It holds you in place. The pull of the sun, that quiet invisible pull called gravity, reaches across 93 million miles of empty space and gently keeps the Earth in its slow, long circle. Without that pull, the Earth would drift off in a straight line and grow colder and forget what summer was. With it, the Earth turns and turns around the sun, once each year, the way a moth circles a lamp without ever quite arriving. You have been carried around that great circle many times now, more times than you can quite picture. You will be carried around it many more. And you have never had to do a thing. Even your days and nights are made by the sun. The light comes, the light goes, and your body has learned, over many long generations, to follow that quiet rhythm. You wake, more or less, when the sun rises. You grow tired, more or less, as it sets. The slow drift of sleep that you are settling into now is, in part, an answer to the sun. The sun has turned away from your part of the world, and your body, very old and very wise, has noticed, and is letting go. All of this is happening as you lie here. The sun does not need to be watched. It does its slow, vast, ancient work whether anyone is looking up or not. It has been doing it for longer than the Earth has had oceans. It will go on doing it for longer than your descendants will remember your name. And the warmth that reaches you tonight, the small remembered warmth of an afternoon, the warmth at the back of your eyelids if you have stood on a doorstep and let the light fall on your face, that warmth is one tiny fragment of all this. One small thread, woven through 8 minutes of empty space, slipped down through the air, and folded gently into your body where it stays. You are made, in part, of sunlight. We will not press the point. But quietly, it is true. For now, let the sun be behind you. We are turning, slowly, outward. The next world is small and very near the heat. Rest. The sun does not mind. Chapter 2, Mercury. Now we drift outward. Not far. Mercury is the first of the planets, the one nearest the sun, the one that has lived its whole life standing closest to the fire. Imagine, if you can, holding your hand a little too near a candle. You do not burn, exactly, but you can feel the air around your fingers grow heavy and warm. That is, in a small way, what it is to be Mercury. Always too close. Always feeling it. Mercury is small. The smallest of the planets, in fact. It is only a little larger than our own moon, and from a distance, if you did not know better, you might mistake it for one. The same pale grey. The same pocked and pitted surface. The same quiet, lifeless look. It is a world that has been weathered by nothing but stones and time. There is no wind on Mercury to wear things down. There is no rain to soften the edges. The craters that fell upon it long ago are still there, almost exactly as they landed, looking very much the way they did when the dinosaurs were still small lizards on Earth. Picture, for a moment, The surface of Mercury. It is a long grey plain, dim and dusty. The ground is broken everywhere by craters, some of them no wider than a teacup, some of them so vast they would take days to cross on foot. The light is strange. The Sun, in Mercury's sky, is more than twice as wide as it is from Earth, and 3 times as bright. It does not warm the sky, though, because there is almost no sky to warm. The blackness above is sharp and starry even in the middle of the day. A sun the size of a soup bowl, hanging in deep black. Shadows that are blacker still. And everywhere, the soft grey of stone and dust. It is not really a place. It is a surface. A patient grey surface, turning very slowly, beneath a sun that does not relent. How slowly? More slowly than you would think. On Earth, a day is the time it takes for the sun to rise, cross the sky, and set, and rise again. About 24 hours. Easy. Familiar. On Mercury, a single day, from one sunrise to the next, takes about 176 Earth days. Almost 6 months. Imagine that. The sun comes up, and then it climbs, and climbs, and climbs, taking weeks and weeks just to lift itself fully into the sky. And then it hangs, almost still, and turns the rocks beneath it slowly to ovens. And then, after months of this, it begins to set, taking weeks again to lower itself toward the far horizon. And then it is dark for months. The night on Mercury is longer than most human pregnancies. The night on Mercury is longer than a school term. There is no hurry, anywhere, on Mercury. And yet the planet itself flies. While its day is slow, its year is short. Mercury rushes around the Sun in only 88 Earth days, the fastest racer of all the planets. Round and round it goes, in less than 3 months, leaning into the heat. It is, in that sense, both very slow and very fast at the same time. Slow in its turning, quick in its going. The mornings take forever and the years go by in no time at all. A strange little world. If you stood upon it, which you should not, you would find the ground hard and dry beneath your feet. The dust would be very fine as flour, and your boot prints would last almost forever, the same way the boot prints on our moon will last for millions of years more, because there is nothing to disturb them. You would weigh less than you do on Earth. You would feel light, as if you were carrying very little. And if you stood in the sunshine, you would feel a heat unlike any heat you have ever known. Not the heat of a warm afternoon. Not the heat of a hot summer day. The heat of an oven that has been left on for 100 years. Around 430 degrees on the warm side. Hot enough to melt lead. Hot enough to make a metal spoon sag in your hand, if you had brought one. And yet, if you walked into shadow, the cold would find you almost at once. The thin breath of nothing that passes for Mercury's atmosphere cannot hold heat. The moment the sun stops touching the ground, the warmth flees. The night side of Mercury falls to nearly 200 degrees below freezing. It is one of the most extreme contrasts in our whole solar system. The same little world, the same small ground, can be hot enough to melt metal and cold enough to freeze every gas in your body, only a few miles apart. A planet of fire and ice, sitting side by side, with nothing in between. And here is something tender and strange. In the very darkest of those craters near the poles of Mercury, in the places where the sun has never managed to reach, not once in billions of years, there is ice. Real water ice. Quietly tucked away in the corners of a sun-baked world. Hidden in shadow that has held forever. Sitting there, patient, waiting, with no one to drink it. It is one of the gentler surprises of our solar system. Even on a planet pressed against a star, there are places the warmth cannot find, and in those places, water sleeps. There are no moons around Mercury. It is the only planet beside Venus that has none. It journeys around the Sun by itself, with no smaller companion turning around it, no quiet partner. Just Mercury, alone, racing in its little circle. It has been doing that for 4,500 million years. It will go on doing it for billions more. A small grey planet, very near a star, turning by itself. The whole inside of Mercury is mostly metal. That is one of its quiet secrets. Beneath that pitted grey skin, deep within the world, there is a great iron heart that fills most of the planet. Mercury is a thin shell of stone around an enormous metal core. It is, in a way, the densest of the small planets after Earth. Imagine, if you like, an apple that is mostly the size of its seed. That is Mercury. Mostly heart. Very little flesh. We are not sure why. There are several patient theories, and astronomers turn them gently over the way you might turn a smooth stone in your hand. Perhaps Mercury was once larger and lost its outer layers in some long-ago collision, and what we see now is the bare metal core, slightly cooled, slightly dusted. Perhaps it formed this way, very close to the Sun, where only the heaviest things could settle. There is no rush to know. The planet will keep its secret as long as it likes. And then there is the largest scar on its face. It is called the Caloris Basin. It is a great round mark, more than 1,000 miles across, left by something enormous that fell against Mercury long, long ago. The impact was so vast that it pushed great rings of hills out around it, and on the very opposite side of the planet, the shock waves passed through Mercury's stone and rose up as a strange jumbled hill country, all of it made the same day, by the same blow. It was, in that moment, a violence beyond any storm you have ever known. And then it grew quiet. And then it stayed quiet for billions of years. That is, perhaps, the deeper lesson of Mercury. That violence ends. That noise ends. That the loudest thing that ever happens to a place eventually becomes, simply, part of its face. The crater is still there. But nothing is still happening in it. The basin is calm. The hills are calm. Mercury sits inside the Sun's hot breath and turns, and waits for nothing. If you look up from Mercury, you will see the Sun, of course, large and bright. But you will also see, on a clear night side, a strange star that is not a star, low on the horizon. A blue marble. A bright steady blue. That is Earth. Seen from Mercury, your home is a small bright dot, hanging in the same dark, no different in shape from the dots you see from your garden at night. You are, from Mercury, a star. There is a strange thing the Sun does in Mercury's sky, and it is worth saying once, quietly. Because Mercury moves in a slightly oval circle around the Sun, sometimes nearer and sometimes a little further, and because it turns on itself very slowly, the Sun does not always march forward across the sky the way our own Sun does. Sometimes, near the closest part of Mercury's orbit, the Sun appears to pause. To slow. Even, for a little while, to drift back the way it came. It rises, it climbs, it stops, it sinks a little, and then it gathers itself and continues on. From certain spots on Mercury, you would see the Sun rise twice in the same long day. It would come up, and pause, and slip below the horizon, and then rise again, and continue on. There is no other planet where the Sun does this. It is a private slow dance between Mercury and its star that nobody is there to watch. The two of them have been doing it, patient and silent, for billions of years. There are no seasons on Mercury, not really. The planet sits almost perfectly upright on its turning, with no slow lean from summer to winter the way Earth has. Every day on Mercury is, in a sense, the same long day. The same sun rises. The same sun sets. The same heat in the light, the same cold in the dark. The planet does not change, only turns. Year after year. Age after age. The patience of it is hard to imagine. Few spacecraft have ever been there. Mercury is difficult to visit, because to fall toward the sun is to fall into a hot place, and a spacecraft must work very hard not to drop straight in. Only a small handful of probes have ever flown close enough to take its picture properly. They have mapped its scars, and counted its craters, and listened for its quiet magnetism, and gone home. Mercury continues. The probes are very small. The planet is very old. The sun is very near. The dance goes on. We will not stay here long. There is little to do on Mercury but listen to nothing happening, very slowly, for a very long time. The sun above, the grey ground below, the long shadows, the long warmth, the long cold. A patient little planet, the closest of them all, going round and round and round. Let it pass behind you now. We are drifting outward again. The next world is hidden under cloud, and stranger than it looks. Rest, if you are still here. Mercury will be fine without us. Chapter 3, Our Venus. The next world is Venus. It is, in many ways, the strangest of all the planets we will visit tonight. Not the largest. Not the smallest. Not the brightest of the worlds we have seen close up. But the strangest, all the same. It is a planet that should, by all appearances, be very much like ours. It is almost exactly the same size as Earth. Almost exactly the same weight. Almost exactly the same place in the long line of distance from the sun. If you had only the dry numbers in front of you, you would say, yes, here is Earth's sister, the world most like our own. And in some ways, that is true. And in every other way, it is not. You have seen Venus, even if you do not know it. In the soft dusk after a quiet day, when the first star comes out before any of the others, that star is very often not a star at all. It is Venus. The brightest of the planets in our sky, brighter than anything except the sun and the moon. People have called it the evening star. People have called it the morning star, when it comes before the sun in the dark hours of early morning. It is one of the first lights human beings ever named. From far away, it looks beautiful. A smooth pearl in the dark. A silver coin. A small soft lantern hanging quietly above the trees. You would think it must be a gentle place. You would think it must be calm. It is not calm. Beneath that lovely pale glow is one of the most extreme worlds in the solar system. Venus is wrapped, head to toe, in a thick blanket of cloud. Not water cloud, the way our skies are. Yellow cloud. Cloud made of sulfuric acid. Cloud so dense that no light from the surface ever reaches us, and no light from the sun ever quite reaches the surface in the way our own sunlight does. The clouds drift around the planet in long fast bands, hundreds of miles an hour high in the air. They turn around Venus once every 4 Earth days, while the planet itself below them turns far more slowly. The whole sky is a sea, and the sea is going one way, and the ground beneath is going almost nowhere at all. If you could sink down through those clouds, slowly, in a way that nothing ever has, you would feel the air around you grow heavier and heavier. By the time you reach the surface, the pressure of the air would be more than 90 times what you feel right now. As if you were 900 meters deep in the ocean. As if you had a small mountain pressing down on every part of you, very politely, all at once. The air at the bottom of Venus is so dense it does not feel like air anymore. It feels like a warm, thick fluid. It moves like syrup. Sound travels through it strangely. A voice, if you could somehow speak, would come out lower and slower than your own. And the heat. The heat on Venus is greater than the heat on Mercury, even though Venus is further from the Sun. That is one of the deepest surprises of our solar neighborhood. The closest planet to the Sun is not, in fact, the hottest. Venus is hotter. Around 460 degrees on the surface, all of the time, day or night, equator or pole. Hot enough to melt lead, again, the way Mercury can be, but constantly, everywhere, without any cooler shadow to crawl into. Venus does not have a cool side. The thick atmosphere holds the warmth in and spreads it everywhere, like a great heavy blanket pulled snug over the whole world. There is no relief. This is the gentle word for what has happened. It is what people have come to call a runaway greenhouse. A planet that, perhaps long ago, had oceans and weather rather like our own. A planet that grew warmer, somehow, and warmer still, and lost its water to the sky, and then to space. A planet whose air slowly thickened with carbon dioxide until it could not let the heat back out. There is, on Venus, a quiet warning. A glimpse of what worlds can become. But that is not a thing for tonight. Tonight, Venus is simply Venus, doing whatever Venus does, with no opinion about us at all. And here is the strangest thing of all about this strange world. Venus turns the wrong way. Every other planet in our solar system, more or less, spins the same direction as it goes around the Sun. The Earth turns, the way you see it turn in any model in a classroom, west to east. The Sun rises in the east and sets in the west. So it does on Mars. So it does on Jupiter. So, more or less, it does everywhere. Except for Venus. Venus turns the other way. Slowly, ponderously, backwards. So slowly that one full turn takes about 243 Earth days. So slowly that a single day on Venus is longer than its entire year. The planet goes around the Sun in 224 Earth days, but it turns on itself in 243. The Sun rises in the west, takes weeks to cross the sky, and finally sets in the east. There is nothing else in the solar system that does this. Venus is the contrarian. Venus is the slow, strange spinner. Venus is, we think, a world that was struck long ago by something so enormous that it set its turning the other way. And then it kept on turning, exactly that way, for billions of years, with no one to correct it. If you could stand upon Venus, though you should not for many reasons, you would find a ground of dim orange light. Not because the rocks are orange, but because the light that filters down through the great yellow clouds is the color of an old lamp. The sky would be heavy and overcast, a kind of glowing dusk that never changes. You would not see the sun directly. You would only see a brighter patch in the cloud, slow and dim and ovenly warm. The ground around you would be plains of dark volcanic rock, gently rolling, gently cracked. Here and there a low round mountain. Here and there a great flat shield where lava once flowed. Venus has volcanoes, many of them, and we are still learning whether some of them are quietly active even now. Most of the surface of Venus was paved, hundreds of millions of years ago, by enormous slow eruptions that resurfaced almost the whole world. Imagine that! A planet repainted from the inside out, all of it, all at once, by molten stone rising patiently from below. It is a difficult thing to picture. It is a difficult thing to live near. The tallest mountain on Venus is called Maxwell Mantes. It rises higher than any peak on Earth, almost 7 miles above the average level of the planet, and on its very top, in the dim orange dusk, there are strange metallic frosts. Not water frost. Not ice. Something made of heavy metal vapors that condense in the slightly cooler air at altitude. A frost of lead, perhaps, or bismuth. A snow that no one will ever ski upon. It is one of the quieter wonders of our solar system. A mountain so warm it has snow made of metal. A small handful of spacecraft have landed on Venus. Mostly long ago, in the days when the Soviet Union sent a brave little series of probes called Venera down through the clouds. They worked, those probes. They sent back pictures of the surface. Pale orange light. Dark rocks. A flat horizon. A single dim sun shape in the cloud above. And then, within an hour or two, the heat and the pressure crushed them, and they fell silent. None of those landers were ever heard from again. Venus does not allow visitors to stay. Venus does not need anyone to stay. Long ago, perhaps very long ago, Venus may not have been like this. Some who study the planets have come to think that Venus, in its early years, had real oceans. Liquid water, lapping on warm stone, perhaps for as long as 1,000 million years. There may have been waves on Venus. There may have been rain. There may have been a sky much like ours, blue and clear. We are not sure. The clues are old and few. But it is gentle to think about. That this severe planet, this oven world wrapped in yellow cloud, may once have been a place where water moved. The sun grew slowly brighter over its long life. The seas of Venus, if ever they were there, slowly steamed away. The water that rose into the sky was, over many ages, lost to space. And the planet darkened and thickened and warmed, and became what it is now. It is a long quiet story told in geological whispers. For tonight, it is enough to know. Venus may once have been someone's home, in a manner of speaking, before anyone we know of was here to call it that. And yet, even now, there is a strange thin layer high above the surface, perhaps 50 kilometers up in those yellow clouds, where the air is gentler. Where the pressure is more like ours. Where the temperature is something a person could almost stand. It is one of the few places off our own planet where, if you somehow built a great floating city in the cloud tops, you could walk outside, with a thin breathing mask, and not be immediately crushed or burned. Nobody has built such a city, of course. Nobody is going to, any time soon. But it is a quietly lovely idea. That above the thick suffocating heat, in the high pale gold of the upper sky, there is a layer of Venus that, in its own way, is calm. As though even the most hostile world has a soft corner, if you know where to look. For all of this, when you look up at Venus from your own garden, none of it is visible. You see only the bright soft glow. The lovely evening star. It is one of the kinder magics of distance. The most violent world close to us looks, from here, like a calm small light. Beauty, sometimes, hides a great deal. We will leave Venus behind. It will keep doing what it has been doing, slowly, in the wrong direction, beneath its yellow blanket, for many ages more. It does not need our attention. The next world is the one you live on. Rest. Venus is far away now. Chapter 4, Earth. This next world is the one you live on. It is a strange thing to say. You have never quite seen it from the outside. You have walked upon it every day of your life, lain upon it every night, breathed its air without thinking, drunk its water, eaten its bread. You know its hills and its corners better than you know any other place. And yet, from here, from out in the dark a small way past Venus, the Earth is not the familiar ground beneath your feet. It is a small round blue thing, swimming gently in the dark. A marble. A coin. A bright soft drop of water hanging in the night. From this far out, you cannot pick out your country. You cannot see your town. You certainly cannot see your house, or your street, or the small light burning in your bedroom. From this far out, the Earth is simply blue and white. The blue is the water. The white is the cloud. Now and then, when the clouds part, you might glimpse a tan or green smudge, the shape of a continent, but it is small. Almost everything you see is sky and sea. Nearly 3/4 of your home is water. From here, you remember that. The astronauts who have looked back at this view, the few human beings who have ever seen the Earth from somewhere not Earth, have all said roughly the same thing. They have said that it is more beautiful than they expected. They have said it looks fragile. They have said it looks alone. They have said it is the only spot of color in a very dark place. Many of them have, more or less, gone quiet. And stayed quiet for a while. It is one planet, of course, among many. We have seen 2 already tonight, and we have many more ahead of us. But none of the others have what this one has. None of them are blue with oceans. None of them are wrapped in air a person can breathe. None of them have anything alive on them, so far as we can tell, in all of our patient looking. The Earth is, for now, a peculiar exception. The one warm room in a very large, very cold house. Look closely at the edge of the planet, where the round blue curve meets the black. There, you will see a thin pale band. It is hardly anything. It looks no thicker than the rind on an orange. That thin pale band is the entire atmosphere of the Earth. That is the whole sky. That is all the air there has ever been to breathe, for every creature that has ever breathed it. Every cloud that has ever rained on every garden. Every storm that has ever swept across any sea. Every word ever spoken, every song ever sung, every breath any animal has ever drawn, has been held inside that pale thin shell. From here, it looks impossibly fragile. From the ground, it feels endless. Both of these things are true. The air of Earth is mostly nitrogen, with a fair share of oxygen, and a tiny pinch of everything else. It is the only air in the solar system that a person can breathe without help. It is the only air that has ever made the lungs of any creature anywhere fill and empty. It is the same air, more or less, that you are breathing now, where you lie. The same air that filled the first lungs to ever take a breath, very long ago, in some warm shallow sea. Beneath that air, the water. There is so much water on this planet that, if you melted down every drop of it and gathered it into a single ball, that ball would be enormous. The oceans cover almost 3/4 of the surface, and they are deep. In some places, almost 7 miles deep. And they are full of life. Almost everything alive on Earth, by weight, is alive in the sea. The land is the lit room with the chairs in it. The sea is the great quiet hall outside. Most of what is here is there. The Earth turns once each day, and that turning is what gives you your sleep. As you lie there now, the world is rotating gently beneath you. Not in a way that you can feel. It is far too smooth for that, far too steady, like the spin of a very well-balanced wheel. But it is happening. The part of the Earth you are on is slowly carrying you eastward, into the deeper night, away from the line where the sun is still setting on somebody else's day. Other people, half a world away, are waking up. Other people, just behind that line, are watching the colors fade from their sky. The Earth turns and turns, day after day, and on its slow turning all of human life has, so far, been arranged. The Earth leans, also, slightly. Its turning axis is not perfectly upright. It is tipped over, just a little, like a slightly drowsy head resting against an invisible shoulder. That tip is the reason there are seasons. For half the year, your part of the world leans toward the sun, and the days grow longer, and the warmth comes back. For the other half, your part leans away, and the days grow short, and the cold returns. It has been doing this for as long as the Earth has existed. Long before any creature was awake to notice. The first leaves of the first trees opened and closed in answer to that slow lean. The first migrating birds turned in their long flights because of it. Your own ancestors built fires in answer to the part of the year when the lean pointed away from the sun. You yourself sleep, in some quiet way, in answer to the spin and the lean. The Earth has, all around it, a great invisible web of magnetism. You cannot see it. You cannot feel it. But it is real. The molten iron deep inside the planet, churning around the planet's hot core, generates a wide, soft magnetic field that wraps the whole world like a great loose cloak. That cloak is one of the kinder gifts of the Earth's structure. It catches and turns aside most of the stream of particles the sun is constantly blowing in our direction. Without that cloak, the air of Earth might have been stripped slowly away over many ages, much as the air of Mars largely was. Because of that cloak, we still have a sky. Because of that cloak, sometimes, when the sun is more restless than usual, the particles slip down along the lines of the field near the north and the south, and they glow softly in the high air, and we call that light the auroras. It is the same wind that touches Mercury and Venus, only here, gently bent into color. There is one moon. It hangs close, a great pale companion, locked into the same slow turn around us. The moon does not glow on its own. It only catches the light of the sun and gives it back to us softer, and that softer light has been falling on this planet for so long that the tides of the oceans rise and fall in answer to it. Twice each day, the seas swell up toward the moon, and then they fall back. The crabs and the fish and the small bright things in the water have all built their lives around that quiet pulse. You yourself, when you have walked on a beach in the late afternoon and watched the water creep up the sand, have been watching the moon, indirectly, pulling on the world. Beneath all of this, the planet is alive in its own slow way. Not in the way that you are alive, but the rocks themselves are moving. The whole great crust of the Earth is broken into vast plates, and those plates drift, very slowly, on the warm syrup of the rock beneath them. Centimeters per year. Less than the speed your fingernails grow. But over many ages, continents have crossed oceans because of it. Mountains have risen because of it. Earthquakes happen, and volcanoes rise, and new sea floor is born, all because the Earth, deep beneath your bed, is very slowly rearranging itself. You will not feel it tonight. You have not really felt it in your lifetime. But it is happening. And then, on top of all of this, all of the slow turning and the leaning and the moving and the breathing of the planet, there is the life. there is no good way to say what it is like, that there are oceans on this world that are full of fish, and forests that are full of birds, and quiet small mammals asleep in burrows under tree roots, and human beings asleep in beds under tile roofs, and somewhere on the other side of the world, children waking up, and somewhere not so far from you, someone almost exactly as tired as you are. The earth is humming with life. Quiet life, mostly. Sleeping life, mostly, right now, in your part of the world. And you are part of that hum. You are one of the small soft creatures the earth is gently turning through the night. The planet does not know your name. But it carries you anyway. The earth has not always looked the way it looks now. If you could pull back further still, not just in space but in time, you would see the continents come unstuck and slide. You would see them gather into one great single landmass, and then break apart again, and then drift back together, and then break apart once more. You would see oceans rise and fall and rise again. You would see ice caps grow down across whole continents and then retreat to the poles. You would see vast forests of strange trees, and then deserts, and then forests again. You would see the surface of the planet remake itself, over and over, like a face that keeps trying on new expressions. And through all of it, the planet has kept turning. The seas have kept moving. The air, in some form, has stayed. You are alive in only one small frame of all this. The hills you know, the coastlines you know, the climate you know, are only this Earth's current shape, this evening's face. In time, even those will change. There is something quietly calming in that, when it is offered gently. Nothing about this world has had to stay the same to be itself. If you could watch one full day go by from far above, you would see the Earth rotate slowly, its lit side facing the sun, its night side wrapped in darkness. Along the line that divides them, the line astronomers call the terminator, the sky on the surface would be that long soft color we call sunrise or sunset. That long soft color is moving, right now, around the planet, at the slow walking pace that follows the spin. Somewhere, always, somebody is watching the sky turn pink. Somewhere, always, somebody is watching the first stars come out. Somewhere, always, somebody is going gently to sleep. We will leave the earth behind us now, as strange a thing as that is to say. We will lift, gently, away. The blue marble will grow smaller. The thin pale ring of atmosphere will shrink to a line. And then we will turn outward, into worlds that are not like home. You will be carried back. There is no need to hurry. Sleep. Earth is right here. Chapter 5, Mars. Now we drift a little further out, away from the soft blue marble we have just left, and the next world begins to glow into view. It is small and it is red. It is the color of an autumn leaf at the end of its season. It is the color of the last clay tile on an old roof. It is the color of rust, because that, in fact, is what gives it that color. Iron rust. Mars is a world that has, in a sense, spent thousands of millions of years slowly turning the wrong color. Its rocks were once gray. Then its rocks were once orange. Now its rocks, and its dust, and its hills, and its plains, are all the same warm red-brown of an old terracotta pot. Mars is small. About half the size of Earth, just a little larger than our moon. It does not feel small, exactly, when you are picturing it, because there is a lot of surface, and the surface is interesting, but in the line of planets, it is one of the smaller ones. Mars is the last of the rocky inner worlds before everything changes. Beyond Mars, the planets become enormous and gaseous and strange. Mars is the last solid ground for a long way. It has 2 moons. Both very small. Both lumpy and odd, shaped less like worlds than like potatoes that have been left at the back of a drawer. The larger one is called Phobos. The smaller is Deimos. They are probably asteroids that wandered too close to Mars long ago and were quietly caught by its pull. Phobos goes around Mars 3 times in a single Martian day, fast and low. Deimos drifts more slowly, further out. If you were standing on Mars and looking up, you would see them as 2 pale moving dots, neither of them as round or as bright as our own. 2 small companions, going quietly about their work. The air on Mars is very thin. About 100 times thinner than the air you are breathing right now. It is also, mostly, the wrong kind of air. Carbon dioxide, mostly. The kind of air that comes out of you, not the kind you breathe in. A person standing on Mars without a suit would not last long enough to be sad about it. And yet, this thin wrong air is not nothing. There is a sky on Mars. There is weather on Mars. There are seasons on Mars. There are even clouds, sometimes, high and thin, made of water ice or carbon dioxide. The planet is alive in the sense that the air still moves and the sky still changes, even if no creature is there to feel any of it. The sky on Mars is not blue. It is the color of butterscotch, more or less. A soft pink-orange dome, dimmer than ours, with a smaller, paler sun crossing it. The sun on Mars looks roughly 2/3 the size it does from Earth, and a little less bright. The light is gentler. The shadows are softer. Even on the brightest day, it would feel, to your eye, like a long late afternoon. There is no harsh midday on Mars. There never has been. Sunset on Mars is one of the strangely beautiful things in our solar system. Here on Earth, our sunsets are red and orange because our blue sky scatters the colors that way. On Mars, the relationship between sky and sun is reversed. The daytime sky is pink. The sunset, when it comes, is blue. A small soft blue glow gathers around the setting sun, and the rest of the sky deepens into a darker pink, and the sun slips down into a blue pool, and then the night begins. There is no sound. There is no bird song. There is, at most, a soft thin wind moving across the dust. The wind on Mars is so light that even strong gusts feel, to a spacecraft on the surface, like a gentle breath. But the wind is patient. Over very long times, it has carved hills, smoothed boulders, swept dust across hemispheres. The wind on Mars is one of the planet's slow patient artists. Mars is cold. Much colder than Earth. The average temperature, across the whole planet across the whole year, is somewhere around 60 degrees below freezing. The warmest summer day at the warmest spot on the planet, near the equator, might briefly creep above freezing. The coldest winter night near the poles can drop low enough that the carbon dioxide in the air itself freezes and falls quietly as a kind of dry frost. It is not a place to picnic. But it is, in its own way, calm. There are mountains on Mars that dwarf anything on Earth. The largest of them is called Olympus Mons. It is a volcano. It is one of the largest known volcanoes in the entire solar system. It rises nearly 14 miles above the surrounding plains. That is roughly 3 times the height of Everest. Its base would cover a country. If you were standing somewhere near it, you would not, in fact, see the top, because the mountain is so wide that the curve of the planet itself hides the summit from anyone walking at its foot. Olympus Mons is so vast it folds the horizon. It has not erupted in a very long time. Most likely it never will again. It just sits there, immense, the way old buildings sit in old cities, patient and unbothered, while the world goes on around it. And there is a canyon on Mars that makes the Grand Canyon look small. It is called Valles Marineris. It runs almost a quarter of the way around the planet, more than 2,500 miles long, and in places more than 4 miles deep. It is so large that, if it sat on Earth, it would stretch from one side of the United States to the other. From Mars' orbit, you can see it as a great red gash across the face of the planet. It was not carved by a river. It is more likely a long crack, opened by ancient movements in the Martian crust, and then widened over time by collapses and slow erosions. A canyon so large it is, from above, the first thing you notice about the planet. The poles of Mars are white, or whitish. They are covered in caps of ice. Some of that ice is water ice. Some of it is frozen carbon dioxide, the dry ice you might have seen in a school science demonstration. In summer, the carbon dioxide cap shrinks. In winter, it grows. The poles breathe slowly in and out, with the long Martian seasons. Each season lasts about half a year by our reckoning, because Mars takes nearly 2 of our years to go around the Sun. The winters are long. The summers are long. Patience is the planet's main weather. Long ago, Mars may have been a much wetter place. There are dry riverbeds carved into its dust. There are deltas where water once spread out into broad slow channels. There are places that look very much, from above, like the bottoms of vanished lakes. There are even some scientists who think there may once have been a real ocean on Mars, covering much of its northern hemisphere, thousands of millions of years ago. If you could go back to that lost age of Mars, you might find a bluer planet, with rain falling, with rivers running, with warm shallow seas in which life, perhaps, just perhaps, was getting started. We do not know. We have not found it, if ever it was. We are still looking. What happened to that water? Mars lost it, mostly. The atmosphere of Mars was once thicker than it is now. But Mars is small, and Mars does not have a strong magnetic cloak the way Earth does. Over long ages, the solar wind, that gentle ceaseless stream from the Sun, slowly stripped Mars of its air. As the air thinned, the surface cooled. As the surface cooled, the water froze, and seeped underground, or escaped quietly upward into space. Mars, in a sense, evaporated. Slowly. Over many ages. Until it became the quiet rust-colored world it is now. Right now, this very evening, there are small machines on Mars. They are wheeled and patient. They have names and missions. They roll, very slowly, across the red dust, sampling rocks, taking photographs, listening for Mars quakes, drilling small careful holes. They take pictures of the pink sky and send them back to Earth. They are the first long arms of a curious species reaching out and gently touching another world. The wind passes across them in the long Martian night. They do not mind. They keep working. There is something tender about the look of Mars in our telescopes. A small red dot, when it comes around close to us, brighter than most stars, faintly orange to the eye. People have looked up at Mars for thousands of years and seen it move strangely across the sky, sometimes forward, sometimes seeming to drift backwards for a while, and they have given it many names in many languages. War, mostly. Fire, sometimes. The red one. The wandering one. Now, when we look up at Mars, we know there are wheels rolling on it. There is a wind blowing across the wheels. There is dust settling on them, slowly, in the long pink afternoon. We have given Mars a new kind of meaning. It is no longer only a dot. It is a place we have been. If you were to stand on Mars, in your suit, in the long pink afternoon, you would feel light. Lighter than you have ever felt. Mars has only about a third of Earth's gravity. A jump that would take you a foot in the air at home would lift you 3 or 4 feet on Mars. Things you have always known to be heavy would feel almost gentle. You could lift a chair with one hand. You could walk for hours without tiring, if your air held out, because your body would weigh so little. There is something appealing about it, when you imagine it from a warm, soft bed. The lightness of an entirely different world. The tilt of Mars, by the way, is almost the same as the tilt of Earth. Just under 25 degrees, very close to our own 23.5. That is one of the reasons Mars has true seasons. Not seasons that would feel like ours, with their warmth and their birdsong, but seasons that change the color of the planet, that drift dust around, that grow and shrink the polar caps, that move the weather. Mars and Earth lean their drowsy heads at roughly the same angle. It is one of the things we have in common with the planet next door. We will leave Mars now, with all its quiet beauty. The little red planet will keep turning, slowly, in the cold. Its winds will keep whispering across its dust. Its old riverbeds will keep waiting, in case anyone, anything, ever passes by. Onward. The next stretch of the journey is wide and empty and almost nothing at all. Sleep. Mars is patient. Mars does not need us. Chapter 6, The Asteroid Belt. You have, perhaps, seen pictures of this part. In films, or in cartoons, or in the imaginations of children who have looked up at the sky. The asteroid belt is often shown as a great churning storm of rocks, tumbling thickly through space, packed together so densely that a spacecraft would have to weave nimbly between them at high speed, dodging boulder after boulder, just to make it through. Most of us, when we picture the asteroid belt, picture something like that. A crowded place. A dangerous place. A swirling cloud of stone. It is not like that. Not even a little. The truth of the asteroid belt is gentler, and stranger, and in some ways more beautiful. It is, in fact, one of the emptiest places in our solar system. If you were dropped into the middle of it and asked to find another asteroid, you would almost certainly not be able to. They are spread out across a vast ring of space between Mars and Jupiter, and the ring is enormous, and the stones in it are tiny compared to the room they have. The average distance between any two large asteroids is many millions of miles. A spacecraft can fly straight through the asteroid belt and never come near a single one. We have done it. We have done it many times. The great craft that left the inner solar system on their way outward, Voyager, Pioneer, Cassini, all of them, passed through this region without any trouble at all. They saw nothing, mostly. Empty space. The Sun behind, a little smaller. Jupiter ahead, a little larger. And, somewhere out of sight, in the great wide dark, the stones, slowly tumbling. So that is the first kindness of the asteroid belt. It is not a crowd. It is a sparse scattering. A handful of seeds thrown across a very large field. There are, all the same, a lot of them. Hundreds of thousands of asteroids large enough to have been seen and named. Probably many millions more, smaller, that nobody has noticed yet. They range in size from rocks no larger than a house to small worlds nearly 600 miles wide. Their shapes are odd. The smaller ones are lumpy, irregular, like potatoes or pebbles or broken old plates. Only the largest ones are round, because only the largest ones have enough gravity to pull themselves into a sphere. The biggest body in the asteroid belt is called Ceres. Ceres is so large, in fact, that it is considered a dwarf planet, the same class as Pluto, which we will visit much later tonight. Ceres is almost 1,000 kilometers across. If you took all the other asteroids in the belt and weighed them together, Ceres would still be a third of the total. It is the heavy-hearted heart of the place. Ceres is pale grey and dusty, with bright spots on its surface that puzzled astronomers for years. Those bright spots, when a spacecraft finally went to look, turned out to be salt deposits, places where briny water had once welled up from below and dried in the cold vacuum, leaving behind small bright stains. There may be, even now, a great quiet ocean of slushy salty water deep inside Ceres. Not the kind of ocean you could swim in. A buried, frozen, gentle ocean. Pressed under the rock, in the dark. The second largest is called Vesta, and Vesta is a strange and lovely thing. About half the size of Ceres, Vesta is shaped less perfectly. Not quite round, slightly lumpy. The whole bottom of Vesta has a huge missing piece, where something enormous once struck it. The crater is so vast that it covers most of the southern half of the asteroid, and the impact threw off pieces that we have, very occasionally, found landed gently on the Earth. There are meteorites on Earth that we know, by their chemistry, are pieces of Vesta. There are small fragments of the distant asteroid that have traveled, slowly, across the long dark, and arrived on a hillside in Africa, or a wheat field in Australia, and been picked up by a farmer who had no idea what he was holding. Pieces of an asteroid sleeping in museum drawers. It is one of the quieter wonders. There are a few other large ones. Pallas. Hygeia. Each of them has its own slightly different shape, slightly different color, slightly different story. Pallas is tilted at a strange angle to the rest of the belt, going around the Sun on its own personal lean. Hygeia is dark and damp, made of stone and ice. Every one of these large ones is, in a sense, a small unfinished world. Worlds that almost became, and never quite did. Because that is the question, of course. Why is the asteroid belt here at all? Why is it a belt of stones, and not a planet? The answer is gentle and sad and a little bit poetic. The asteroid belt is, more or less, the leftover material from when our solar system was forming, somewhere it could not quite settle. Around every other clear orbit in the inner solar system, the dust and the gas and the small rocks all gathered, slowly, into one body. They became Mercury. They became Venus. They became Earth. They became Mars. But in this particular orbit, just past Mars, just before Jupiter, the gravity of Jupiter was so strong that it kept stirring the pot. Every time the small bodies in that region began to clump together, Jupiter's pull would knock them apart again, or send them flying, or change their courses just enough that they could not quite stay together. So the planet that might have formed there never did. The pieces remained pieces. And those pieces are what we now call the asteroid belt. A planet that never finished assembling itself. A planet held in pause for 4,500 million years. There is something quietly tender about that. A place in the solar system where a planet was meant to be, and never quite was. The asteroids drift in that place still, slow and unhurried, going around the Sun in their long careful circles, never gathering, never separating, simply being what they have always been. If you were out there, in a spacecraft, drifting between the stones, you would mostly see darkness. The Sun would be smaller than it is at home. The light would be paler. The stars all around would be sharp and bright, because the air around you would be no air at all. Now and then, very rarely, you might see a small grey rock drift past, slowly turning, lit on one side by the distant sun. It would not be in a hurry. None of them are in a hurry. They have all the time there ever was. The asteroids do not all stay perfectly in the belt. Sometimes, one of them is nudged by Jupiter, or by a collision with another stone, and it falls out of its slow circle and drifts inward, toward the Sun. Most of those wandering asteroids never come anywhere near anything. But every so often, one passes near the Earth. Every so often, one falls into our atmosphere and burns brightly as a shooting star, and the small dust of it settles, quietly, on rooftops and gardens, and is washed away by the next rain. The asteroid belt has been quietly raining small pieces of itself on the Earth for as long as the Earth has had a sky. You yourself have probably stood under a sky in which a fragment of an asteroid was, at that moment, glowing into nothing. You did not need to know. Spacecraft have visited a few of the larger asteroids. A small mission called Dawn went to both Vesta and Ceres, swung gently into orbit around each, took thousands of careful photographs, and learned what their surfaces were made of. There are samples of asteroid material now on Earth, in laboratories, in clean little jars, brought back by small careful missions that have flown out, gathered a pinch of dust, and turned for home. We are slowly getting to know our solar system's quiet middle, one stone at a time. Most of the stones are still anonymous. Most of them will never be named. The asteroid belt is not a noisy place. It is not even, really, a place. It is more of a region. A long thin ring of slow tumbling. If you stood in the middle of it and held your breath, you would hear nothing, because there is nothing to hear, and you would see, mostly, the same deep dark you would see anywhere else out here. The whole belt is, in a sense, an emptiness with a few quiet stones in it. Not the storm we imagined. Not the chaos we were told about. Just the long careful orbit of leftover pieces, taking their time. Not all of the asteroids in our solar system live in the belt, as it turns out. There are two other large gatherings of stones that share an orbit with Jupiter itself. They are called the Trojans. They sit in two great patient clouds, one a little ahead of Jupiter on its long path around the Sun, one a little behind. They have been quietly held there, in two stable points where the pull of Jupiter and the pull of the Sun cancel each other gently out, for almost as long as the solar system has existed. Like two old companions walking with a friend, one slightly ahead, one slightly behind, never catching up, never falling behind. The Trojans are a quieter family of asteroids than the main belt, but they are very old, and very still, and they have been doing the same slow walk forever. The asteroids themselves come in different kinds. Some are dark and full of carbon, the way charcoal is dark. Some are paler, made mostly of silicate rock, the same material that makes up most of the rocks beneath your house. A few are bright, made mostly of metal, the bare iron and nickel hearts of long-ago worlds that broke apart and left their cores behind. Each of these types tells a small piece of the story of how the solar system formed. The dark ones gathered far from the Sun, where it was cool enough for water and carbon to stick to dust. The bright metal ones gathered closer in, or were the surviving cores of worlds that lost their rocky outsides. The whole belt is a kind of archive. A library of how planets are made, scattered across a vast quiet shelf, waiting for anyone who wants to read it. We will leave the belt behind. We have not, in any meaningful sense, slowed down for it. The stones have not noticed us pass. They are not the sort of place to notice anything. The next world is the biggest in our solar system. We are about to feel it pull at us. Sleep. The stones will keep tumbling without us. Chapter 7. Jupiter. Now we begin to leave the small worlds behind. Until this point, every place we have visited tonight, the sun aside, has been made of rock. Mercury was rock. Venus was rock under cloud. Earth was rock under water under cloud. Mars was rock under dust. Even the asteroid belt was rocks, slow and scattered. Now we cross into something different. We cross into the part of the solar system where the planets are no longer little hard worlds you could stand upon. The planets, from here on, become enormous. They become soft and gaseous and strange. They become the giants. And the first and largest of them is Jupiter. Jupiter is, simply, vast. There is no other word that quite fits. Jupiter is so large that if you took every other planet in our solar system, the 8 others, the dwarf planets, every moon, every asteroid, every drifting stone, and weighed them all together, Jupiter would still be more than twice as heavy. Jupiter is more than 300 times the mass of Earth. You could fit about 1,300 Earths inside it. It is, in every meaningful sense, the second largest thing in our solar system, after the Sun itself. You could almost call Jupiter a star that did not quite become a star. If it had been a few dozen times bigger, the pressure in its center might have lit a fire of its own, and we would have 2 suns in our sky, one warm and gold, one cool and faint. But it was not big enough. So it is a planet, instead. A planet that almost was a star. You have probably seen pictures of Jupiter, even if you do not remember them. It is the great striped one. Its surface, or what looks like its surface, is wrapped in long horizontal bands of cream and tan and salmon and brown. Some of the bands move one direction. Some move the other. They are not bands of paint. They are vast belts of cloud and wind, blowing across the planet at hundreds of miles an hour, in stripes that go all the way around. The whole face of Jupiter is, at all times, restless. It is a slow-patterned restlessness. The lines on the giant are themselves moving rivers of weather. And in the middle of those bands, off in the southern half of the planet, there is a great red oval the size of a world. It is called the Great Red Spot. It is a storm. A single storm, swirling slowly, that has been spinning on Jupiter for at least 350 years, perhaps longer. We have been watching it for as long as we have had telescopes good enough to see it, and it has always been there. 3 to 4 times wider than the entire Earth. Older than every nation now alive. Slow, patient, red-brown, going around and around the same place in the same vast sky, for centuries. There is no storm anywhere on Earth that comes close to it. There is no storm even in the same league of size or longevity. Jupiter's red spot is one of the longest-lived weather systems in the solar system, and we have not even been around for the whole of its life. Jupiter is made, like the Sun, mostly of hydrogen and helium. There is no solid ground anywhere on it. There is no surface where you could land a spacecraft. If you dropped down into Jupiter, you would fall through layers of clouds, first thin white ones, then thicker brown and red ones, then dark crushing ones, and the air around you would grow denser and denser and hotter, and you would never land on anything. You would simply, somewhere very deep, be crushed and dissolved by the weight of the atmosphere above you. Deep enough in, the hydrogen begins to behave like a liquid. Deeper still, like a strange metallic liquid that conducts electricity, swirling around what is probably a small rocky core at the very heart of the planet. Or perhaps no core at all. We are not entirely sure. Jupiter does not give up its secrets quickly. A day on Jupiter is short. Despite its enormous size, Jupiter turns very quickly. Once every 10 hours, give or take. That is the fastest rotation of any planet in our solar system. The giant spins. It spins so fast, in fact, that the spinning itself has slightly flattened the planet. Jupiter is a tiny bit shorter from pole to pole than it is around the equator. You can see this in pictures, if you look. The giant is just slightly squashed, like a softball that someone has gently pressed. The year on Jupiter, however, is long. Nearly 12 Earth years to go all the way around the Sun. Jupiter is about 5 times further from the Sun than Earth is. The Sun, from Jupiter, looks small. Only about a fifth the size we see it from home. Bright still, but a much smaller disk against the dark. The warmth at Jupiter is much less. The light is much less. Jupiter has its own great cold storms going on out there, lit by a sun that, from where it sits, is closer to being a very bright star than a friendly hearth. Jupiter has a great many moons. Almost 100, last we counted, and the count keeps going up as we find more small ones. Most of them are tiny captured asteroids, dark and lumpy, wandering in long lopsided orbits. But there are 4 moons of Jupiter that are not like the others. They are large. They are round. They are worlds in their own right. They were the first moons of another planet ever seen by human eyes, when Galileo turned his small telescope toward Jupiter 400 years ago and saw 4 little stars near the bright disk that moved, night after night, in a regular pattern, around the planet. He had discovered that other worlds had moons too. He had quietly changed everything we thought we knew about our place in the universe. We still call them the Galilean moons. The closest of them is called Io. Io is roughly the size of our own moon, and it is the strangest. Io is the most volcanically active body in the whole solar system. Its entire surface is covered in active volcanoes, spouting sulfur and lava in great soft plumes that rise far above its surface. It is pulled and squeezed constantly by the gravity of Jupiter and the other large moons, and that squeezing keeps its insides hot, and that heat keeps spilling out. From a distance, Io looks like a great mottled pizza. Yellow, orange, white, sulfur in every shade. It is, in its way, terribly beautiful. The next is Europa. Europa is also about the size of our moon, but its surface is utterly different. Europa is wrapped in a smooth shell of ice. The whitest, cleanest world in the solar system, by appearance. The ice is crossed by long dark cracks, like a great frozen pond with a million slow fractures. And beneath that ice, almost certainly, there is an ocean. Not a small one. A great deep ocean of liquid salty water, possibly twice as much water as all the oceans on Earth combined. It has been sitting there, in the dark, kept warm by the same tidal squeezing that lights Io's volcanoes, for billions of years. There are people who study Europa who think very gently that, if life ever started in that warm dark sea, it may still be there. We do not know. We have not been able to look. It is one of the quietest hopes of our space age. The third is Ganymede. Ganymede is the largest moon in our entire solar system, larger even than the planet Mercury. It has its own faint magnetic field, the only moon that does. It is icy on the outside, rocky on the inside, and like Europa, it almost certainly has a hidden ocean under its ice. The fourth is Callisto, an old battered world, more heavily cratered than any other body we know, marked from edge to edge by impacts that have built up across the long quiet ages. Around these four large moons there is a host of smaller ones. Jupiter, from a distance, is not just one planet. It is a small system of its own. A king in the middle, holding court to dozens of attendants. If you stripped away the Sun and put Jupiter at the center, it would, in a strange way, look like a miniature solar system. Most of its smaller moons go round and round in their patient orbits, never knowing each other, never crossing paths, simply going on. Jupiter also has rings. Not the bright famous rings we will see at Saturn, but faint thin dusty ones, made of tiny particles flung off the surfaces of its inner moons over long ages. You can hardly see them. You would not notice them if you were not looking. But they are there. Around the whole giant, holding it in its great magnetic embrace, is a field of magnetism larger than any other in the solar system. Jupiter's magnetic field is so vast that, if you could see it with your eyes, it would appear larger in the sky than the full moon does from Earth. It catches particles. It bends radiation. It creates auroras at Jupiter's poles, glowing in colors we have only just begun to photograph. It is the kind of field that would, in earlier ages, have been mistaken for the planet itself. Jupiter is, in many ways, more than the visible giant. Jupiter is also the great invisible shell around it. There is a quiet generosity to Jupiter, too, that you might not have thought of. Because Jupiter is so large, its gravity reaches very far. Many of the asteroids and comets that wander loose through the outer solar system, that might otherwise eventually have fallen toward the inner planets, are caught and flung aside by Jupiter. The giant acts, in a sense, as a slow patient guardian. Many of the worst impacts that might have struck the Earth across the long age of our planet were diverted by Jupiter's quiet pull. We do not always think of the great planets as having any relationship to us. But Jupiter, sitting calmly in its orbit, has been keeping our inner family a little safer for a very long time. It does not know that it is doing it. It is doing it anyway. We will leave the giant slowly. There is no hurry. Jupiter has been turning for thousands of millions of years and will turn for thousands of millions more. Its storm will spin a little longer, perhaps. Or it will quiet. Either way, the planet will continue. The moons will continue. The bands will continue. The great red spot will go round and round in its old corner of the giant southern half. The next world we visit is the one with the rings. The most photographed planet in the solar system. The one that nobody ever quite gets used to seeing. Sleep. Jupiter is so large it cannot help but carry us a little while longer. Chapter 8. Saturn. The next planet is, in many people's gardens, the favorite. It is the one that always sounds slightly unreal when you describe it. It is the planet with the rings. Saturn is the second largest planet in our solar system. Only Jupiter beats it. It is enormous, about 9 times wider than Earth. You could fit hundreds of Earths inside it. Like Jupiter, it is a great soft world of hydrogen and helium, with no real solid surface, just deeper and deeper layers of gas. Like Jupiter, it has bands of cloud, though Saturn's are paler and softer, a quieter palette of cream and gold and tan. Like Jupiter, it spins quickly, a single day takes only about 10.5 hours, unlike Jupiter, that spinning has made the planet slightly squashed, just a little wider around the middle than from top to bottom. But of course it is not the planet itself that holds your eye. It is the rings. The rings of Saturn are one of the great quiet wonders of the solar system. They are so wide that they would, if you placed them between the Earth and the Moon, very nearly span the whole distance between the two. From edge to edge, the rings stretch hundreds of thousands of kilometers across. And yet, for all that width, they are astonishingly thin. In most places, the rings of Saturn are only a few tens of meters thick, top to bottom. If you scaled the rings down to the size of a dinner plate, they would be far thinner than a single sheet of paper. They are an enormous flat record, a great vinyl disc spinning around the planet, almost impossibly thin, almost impossibly bright. The rings are made of ice and rock. Mostly ice. Tiny chunks, mostly. Some of them as small as dust. Some as large as a house. Each one going round Saturn in its own quiet circle, all of them moving in step, all of them lit by the distant sun. From far enough away, the whole thing looks like a solid pale gold band. From up close, you would see the rings break apart into uncountable individual pieces, each of them slowly tumbling, each of them following its own gentle path. Snow, in a way. A great spinning ring of snow, lit from the side, drifting forever. Where did the rings come from? We are not entirely sure. They may be the broken pieces of a moon that wandered too close to Saturn long ago and was torn apart by the planet's pull. They may be material that simply never managed to clump into a moon at all. They may be, in geological terms, surprisingly young, perhaps only 100 million years old, which is recent by the standards of a 4.5 billion-year solar system. They may, in fact, slowly disappear over the next few 100 million years, falling gently into Saturn or drifting away. They will not be there forever. They are, in cosmic terms, a current display. We are lucky to be alive while Saturn is wearing them. The planet itself, beneath the rings, is calm and pale and very large. Like Jupiter, it has weather, but Saturn's storms are subtler. They are quieter. Every few decades, a great pale storm rises in one of Saturn's bands and circles the planet, brighter than the surrounding cloud, and then it fades. There is a permanent feature near Saturn's north pole that nobody quite expected. A hexagon. A great six-sided shape made of swirling cloud, larger than the Earth, with each side of the hexagon thousands of kilometers long. Nobody has ever seen anything quite like it elsewhere. It has been there for as long as we have been watching, drawn into the clouds by patterns in Saturn's winds that we are still trying to understand. A great calm geometric figure at the top of the world, slowly turning. Saturn is the least dense of all the planets. So little, in fact, that if you had a bath big enough, Saturn would float in it. Of course there is no such bath. But it is one of those gentle facts that helps you to picture how soft the giant really is. It is enormous, but very puffy. Mostly gas, mostly empty, mostly air. A great pale balloon of a planet rolling slowly around the Sun in a long quiet circle. The year on Saturn is long. Almost 30 Earth years to make a single trip around the Sun. A child born when Saturn began its year would be very nearly 30 years old when the planet returned to its starting point. Most of our lives, the planet has not finished a single orbit. Saturn has many moons. More than 140 known, last count. Most of them small. Some of them strange. A few of them very, very interesting. The largest by far is Titan. Titan is the second largest moon in our solar system, after Jupiter's Ganymede, and Titan is the only moon anywhere with a thick atmosphere of its own. A real sky. Pale orange, hazy, much like the sky of the early Earth might have looked. There is weather on Titan. There are clouds. There is rain. But the rain on Titan is not water. It is too cold for water on Titan. The rain on Titan is liquid methane. The lakes on Titan are made of methane and ethane. The rivers on Titan flow with the same liquid that powers your gas stove. There are great cold lakes near Titan's North Pole, hundreds of kilometers across, glassy and dark. A spacecraft once landed on Titan. It sent back pictures of a dim orange sky over a flat plain of small icy stones. It worked for a few hours. Then the cold took it. Titan keeps its lakes. The second great moon of Saturn worth knowing tonight is Enceladus. Enceladus is small. Much smaller than Titan. It is a little white iceberg of a moon, covered in clean fresh snow, the brightest body in the entire solar system by reflectivity. And from the bottom of Enceladus, near its south pole, great plumes of water vapor shoot out into space, hundreds of kilometers tall. They come from cracks in the ice called the tiger stripes. Beneath those cracks, almost certainly, is another hidden ocean. Salty. Warm enough. Full of organic chemistry. The spacecraft Cassini flew through those plumes more than once and tasted them, and found that they contain almost everything you would need to feed simple life. We do not know if life is there. We have not been able to look in the right way yet. But Enceladus, small and bright and quiet, may be one of the most interesting places in our solar system. There are other moons too. There is Mimas, which has an enormous crater on its face that makes it look, eerily, like a small grey moon from a story. There is Iapetus, which is white on one side and black on the other. There is Hyperion, which spins chaotically, never the same way twice. There is Phoebe, far out and backwards, almost certainly a captured Kuiper belt object that wandered too close long ago. Each one of them is its own small story. Saturn has all of these tucked around it, like a great gentle queen surrounded by attendants of all sorts. The most extraordinary visit to Saturn was made by a spacecraft called Cassini. It arrived in 2004. It stayed for 13 years. It mapped the rings. It photographed the storms. It dropped a probe onto Titan. It flew through Enceladus's plumes. It found new moons. It watched a season turn. And in 2017, when it was nearly out of fuel, the people who flew it sent it, on purpose, into Saturn's atmosphere. It burned up like a small bright meteor over Saturn's cloud tops. It is the only spacecraft humans have ever made that is now, in a sense, part of Saturn itself. A small bit of metal added to the giant, to keep its moons safe from contamination, to give the mission a quiet end. You can see Saturn from Earth without any telescope at all. It is one of the planets that shines in our night sky, a soft yellow steady light, never twinkling. If you have a small telescope, even a cheap one, you can see the rings as a thin pale halo on either side of the planet, and there is a moment when most people see that view for the first time and go very quiet. It looks not quite real. It looks like a model. It looks like someone has painted a planet onto the inside of the telescope. But it is real. It is right there, hanging in the dark, slowly turning, slowly drifting, going about its long quiet life. There is something it is worth knowing about why Saturn has its rings, and why no other planet has rings quite like them. Around every large planet, there is a certain distance, very close to the planet itself, called the Roche limit. Inside that distance, the gravity of the planet pulls hard enough on any large object that the object cannot hold itself together. If a moon ever drifted inside that boundary, it would slowly come apart, broken into chunks by the planet's pull. Those chunks would spread out into a ring. Jupiter's faint rings, Uranus's narrow ones, Neptune's dim ones, are all inside their planet's Roche limits, made of material that could not stay solid that close. Saturn's rings sit there too. And because Saturn has the most ice in its system, and because something happened to feed it ice over the ages, perhaps a moon torn apart, perhaps a great icy comet captured and shattered, perhaps both, Saturn's rings ended up brighter and wider and grander than anyone else's. They are the gift of a coincidence and a position in space. Other planets have rings. Saturn has the rings. Saturn is tipped over too, by the way, though much less dramatically than Uranus, whom we will meet next. Its axis leans about 27 degrees, much like our Earth's 23. That tilt gives Saturn proper seasons, each one lasting about 7 of our years. Over those years, the rings catch the light differently. Sometimes they are tipped wide open toward us and you can see them at their fullest. Sometimes they are seen edge on and almost vanish from view, slim to a thin pale line across the planet. The look of Saturn changes slowly with the years. The light is always shifting. The geometry is always turning. We will leave Saturn now, with all its rings, with all its moons, with its calm pale hexagon at the top. The planet does not need us to stay. It has so much going on. The next world we visit will be quieter. It will be tipped on its side. It will be pale blue. Sleep. Saturn is steady. Saturn is patient. Saturn is going nowhere. Chapter 9, Uranus. Now we drift further still, into the deeper dark. The sun behind us is shrinking. From here it is no longer a warm yellow disk. It is a small bright star, brighter than any other, but no longer obviously a sun. The light around us is dim. The cold is, more than ever, simply how things are. We are entering the outer solar system. We are entering the part of our neighborhood that humans have only barely begun to visit. The next world is Uranus. It is the first of the two ice giants, and it is one of the strangest worlds we will see tonight, not for what it looks like, but for the way it lies. Uranus is tipped over. Almost completely sideways. While every other planet in our solar system spins more or less upright, with its axis pointed roughly toward the same general direction as the Sun's north pole, Uranus is tilted by almost 98 degrees. It lies on its side. It rolls around the Sun like a ball that has fallen over and is being slowly pushed along the floor. We are not sure exactly why. The most likely answer is that, very long ago, in the chaotic early days of our solar system, something enormous struck Uranus, perhaps a body the size of Earth, and knocked the whole planet over. And then the planet, having been struck, continued on, sideways. It has been sideways ever since. For 4,500 million years, this huge world has been quietly rolling on its side around the Sun, and nothing has ever stood it back up. Because of that strange tilt, the seasons on Uranus are unlike any others in the solar system. A year on Uranus takes 84 Earth years. And because Uranus lies on its side, each pole spends about 42 Earth years pointed at the Sun, and then 42 Earth years pointed away from it. Imagine that. 42 years of constant daylight at one pole. 42 years of constant darkness at the other. And then they swap. The Sun rises slowly, takes years to climb the sky, takes years to fall, and finally sets, and then is gone for a generation. The pace of life there, if there were any life, would be the pace of geological time. People who study Uranus speak of its seasons the way most of us speak of ages. Uranus is a pale blue-green color. A soft, slightly minty blue, with very little detail. Where Jupiter has its bands and its great red storm, where Saturn has its rings, Uranus, from outside, looks almost smooth. A featureless pale ball. Its clouds are buried deep beneath thick haze. Its weather is hidden under layers of methane in the upper atmosphere, which absorbs the red light from the distant sun and lets only the blue and green through. The whole planet looks calm, but that calm may be only a kind of veil. Beneath the haze, there is weather. There are storms. There are fast winds. We just do not see them from outside very often. Uranus is large. 4 times the diameter of Earth. About 15 times its mass. But it is much smaller than Jupiter or Saturn. It is in the same family as Neptune, the next planet, the two of them often called the ice giants. The word ice here does not quite mean what you might expect. The ice in an ice giant is not frozen water alone. It is a strange hot dense mixture of water, methane, and ammonia, deep beneath the upper atmosphere, pressed by the weight of the planet into a thick fluid state. There is no solid surface on Uranus. There is only deeper and deeper haze, then deeper and deeper liquid, then, perhaps, a small rocky core somewhere very far in. Uranus was the first planet in our solar system that was actually discovered. The other inner planets, the ones you can see by eye, have been known about for as long as there have been people looking up. Mercury, Venus, Mars, Jupiter, Saturn. All of them named by ancient peoples in many languages. But Uranus was found in 1781 by a kind, quiet astronomer named William Herschel, who was looking through a telescope from his garden in England and noticed a small disk that did not behave like a star. It moved. It was a planet. It was the first new planet anyone had discovered in recorded history. The world, when the news got around, was very astonished. Until that moment, people had assumed that the solar system was complete, that we knew everything that was there. And then, suddenly, there was another planet, and the universe was a little larger than anyone had thought. Uranus has rings. Faint, dark, narrow rings. 11 of them, mostly, although there are some fainter ones too. You cannot see them well from Earth. They are made of small dark chunks of material, and they were only discovered in the 1970s, when astronomers were watching Uranus pass in front of a distant star and noticed the star flicker several times, before and after the planet itself blocked it. Something around Uranus had blocked the starlight. There were rings. There had been all along. Uranus has moons. About 27 of them, last count. They are named, charmingly, after characters from English literature, mostly Shakespeare and the poet Alexander Pope. Miranda, Ariel, Umbriel, Titania, Oberon. They are all icy, all relatively small. Miranda is the strangest. Its surface is a patchwork of utterly different terrains, as if pieces from several different worlds had been broken and glued together, with great cliffs miles high. Some scientists think Miranda was, at some point, shattered by an impact and slowly reassembled itself. Others think the wild surface is just the result of intense ancient activity. Either way, Miranda is one of the oddest small worlds we know. A puzzle of a moon. The atmosphere of Uranus is the coldest place in our solar system, in fact, by official measurement. The upper layers of cloud get down to about 224 degrees below freezing. Colder, in some places, than Neptune, which is further from the Sun. Uranus, for reasons we do not fully understand, seems to lose more heat from inside itself than it gains from the Sun, while Neptune, by contrast, gives off more heat than it receives. The two ice giants are almost twins in size and composition, but they are different in subtle ways, and nobody is entirely sure why. The magnetic field of Uranus is strange too. It does not run neatly through the planet from one pole to the other, the way Earth's does. It is tilted at a great wild angle compared to the planet's rotation. It does not even pass through the center of Uranus. The whole magnetic field is offset, lopsided, slightly tipped, as if the planet had been struck not just on its outside but in its deepest core, and the field had never recovered. From within the great pale blue ball, the magnetism wobbles and bends in a way that no other planet does. Only one spacecraft has ever visited Uranus. It was Voyager 2, in 1986. The visit lasted only hours. The spacecraft flew through the system at high speed, taking pictures, sniffing the magnetic field, counting moons. Then it was gone, on its way to Neptune. Nothing else has been back. Almost everything we know about Uranus, beyond the careful long looks of telescopes, came from that single brief flyby. It is a planet we have, in a sense, barely visited. There may be much we do not know about Uranus, still, simply because we have not been back to look. You can see Uranus from Earth, just barely, with the naked eye, on a very dark clear night, if you know exactly where to look. It is dim. It is small. It looks like a faint star that does not twinkle. You would not pick it out unless you were trying. But it is there, slowly turning, almost imperceptibly drifting against the stars, tipped on its side, dreaming 40-year summers and 40-year winters. There is something soothing about a planet that does not do anything spectacular, that simply lies there in its quiet pale blue. Uranus does not have a great red spot. It does not have ostentatious rings. It does not have weather you could watch through your kitchen window. It is the kind of world that, when described, sounds underwhelming. And yet, the more time you spend with the idea of Uranus, the more it grows on you. The patience of it. The strangeness of being knocked sideways and continuing on. The endurance of 4,500 million years of lying down. There is, perhaps, something a tired person can take from Uranus tonight. A planet that did not have to fight to be upright in order to keep going. A planet that simply rolled, and kept rolling, and was still, in its own way, fine. The moons of Uranus, those literary moons, all named for spirits and lovers from stories long set down on paper, drift around it in their odd tilted orbits. Because Uranus lies on its side, its moons also go round it sideways, like the planks of a great slow water wheel turning on its edge. Miranda is small and battered. Ariel is brighter, with grooves carved across its face. Umbriel is dark. Titania, the largest, is roughly the size of the largest moons of the other giants, although still much smaller than our own. Oberon, on the outside, is heavily cratered, the kind of moon that has been simply absorbing impacts for ages, doing nothing else. Each of them, in its own small way, was named, and is up there now, going around the tipped planet in the long blue cold. There is a small chance that, in the next 20 years or so, we may send another spacecraft to Uranus. Plans are being discussed. Funding is being weighed. Nothing is decided. But the planet is, in the slow patient way of these things, slightly more in our minds than it once was. If we do go, we may find that Uranus is much more interesting up close than from afar. Its haze may part, in certain places, to show us deeper storms. Its rings may have details we have not yet seen. Its moons may have stories. Or perhaps not. Perhaps the planet is exactly as quiet as it looks. Either way, we will know more about it than we do now, which is little. We will leave Uranus now, with its long tilted seasons, its dim pale blue, its great soft silent sky. It does not mind. It does not even notice. The planet has been lying on its side for so long that it has, in a way, made peace with its strange position. We are passing through. The planet is staying. The next world is the last of the planets in our journey. Then we will enter the wide cold ring beyond, and finally meet the small bright heart at the end of the road. Sleep. Uranus rolls slowly. Uranus does not mind. Chapter 10, Neptune. Now we drift on, into the deepest dark of the planets. Neptune is the last of them. The 8th planet from the Sun. The further world that, more than any of the others, marks the edge of the planetary family. From here, the Sun is very small indeed. A bright pinpoint, no longer obviously a disk. The light is dim. The cold is profound. Neptune sits in this dark, calm and deep blue, almost the same size as Uranus but somehow more vivid. As if the planet has gathered itself in a way that Uranus, with its tipped softness, did not. Neptune is blue. Deep blue. The blue of a very late evening sky. The blue that comes after twilight has begun to slip away into night. It is, by a long way, the deepest blue any planet shows. Where Uranus is pale mint, Neptune is rich navy, with subtle pale bands and the occasional white wisp of cloud. The color comes from the same source as Uranus, methane in the upper atmosphere that absorbs red light and lets the blue come back at you. Why Neptune is bluer than Uranus, even though they have similar amounts of methane, is one of those small puzzles that has not yet been fully solved. The two planets are nearly twins, in size and weight and makeup, but they are not quite the same. They are, perhaps, like brothers raised in similar houses who somehow grew up to have different faces. Neptune is far. It is the furthest of the 8 planets, about 30 times further from the Sun than Earth is. The Sun, from Neptune, looks no larger than a bright star, a single sharp point. Sunlight at Neptune is about 900 times dimmer than sunlight on Earth. If you stood on a piece of cloud in the upper atmosphere of Neptune at midday with the Sun directly overhead, you would have less light than you have, on Earth, in the moment after sunset on a clear evening. A kind of perpetual blue dusk. The whole planet exists in that long deep dusk, all of the time. A year on Neptune lasts 165 Earth years. That means Neptune has, since it was discovered, just barely completed one orbit. It was found in 1846. It completed its first full orbit since its discovery in 2011. There are people who watched Neptune as a small dot in the same place in the sky and waited, generation after generation, to see it return to where it had been first seen, and that wait was longer than any single human life. The planet finishes its year in slow motion, by our standards. It does not hurry. Neptune was found in a remarkable way. It was the first planet discovered by mathematics rather than by accident. By the early 1800s, astronomers had been carefully measuring Uranus's motion across the sky, and they had noticed that Uranus did not move quite the way it should. Something out there was pulling on it. Something further out. A small French mathematician named Leverrier worked out, using only pen and paper and very careful numbers, exactly where in the sky the unknown planet should be to explain Uranus's wobble. He sent his prediction to an observatory in Germany. They pointed their telescope at the spot. Neptune was there. It was almost exactly where his arithmetic had said it would be. It was, in many ways, one of the most beautiful moments in the history of science. A planet that had been hiding in the dark for so long, and that no one had ever seen, was, in a single evening, named. We had reached out across the dark with mathematics, and gently touched a world. The atmosphere of Neptune is wild. It has the fastest winds in the entire solar system. Truly the fastest. Winds at the upper cloud levels can blow at more than 1,500 kilometers per hour, and possibly closer to 2,000. That is faster than the speed of sound on Earth. Faster than any storm we have ever known. Neptune, despite being far from the Sun, despite getting almost no warmth from above, has weather that is more violent than anywhere we will visit tonight. Why this is so is another small puzzle. Perhaps the planet's own internal heat, the warmth still leaking out of its deep interior from when it formed, drives those winds. Perhaps it is the long dim seasons that gather energy in odd places. We do not know. But the winds of Neptune are something to picture in the dark. Vast, almost silent in our minds, blowing through clouds of methane ice, faster than any aircraft, in a cold deep blue sky. When Voyager 2 arrived at Neptune in 1989, it took photographs of a large dark oval in Neptune's atmosphere, very like the Great Red Spot of Jupiter, but blue-black. It was named, simply, the Great Dark Spot. By the time Hubble looked again a few years later, it had vanished. New dark spots have come and gone since. Neptune's storms, unlike Jupiter's, do not seem to last for centuries. They rise. They drift. They dissolve. The planet keeps producing them. Neptune has 14 known moons. The largest by far is Triton. Triton is a strange moon. It is almost certainly not a moon that Neptune was born with. It is almost certainly a small icy world that wandered too close, long ago, from the wide cold ring beyond, and was caught. We know this because Triton orbits Neptune the wrong way. Backwards. Every other large moon in our solar system goes the same direction around its planet as the planet spins. Triton goes the other way. The only reasonable explanation is that Triton was captured. It was once a separate small world, going about its own business in the further dark, and Neptune reached out and gently held on. It has been held ever since. Triton is icy. It is one of the coldest places in the solar system. Its surface temperature is somewhere around 235 degrees below freezing. And yet, even there, even at that cold, Triton has activity. It has volcanoes, of a strange dark kind, that erupt not lava but nitrogen and dust, in long plumes that spread across its surface. Voyager 2 saw those plumes, faintly, when it flew past. A moon, far from any warmth, somehow still alive enough to spit small plumes of cold gas into the dark. Neptune has rings, too. 5 of them. They are faint, narrow, and made of dark fine material. They are not the showpieces of Saturn. They are easy to miss. But they are there, going round the planet in the long blue darkness. The magnetic field of Neptune is, like the magnetic field of Uranus, tilted and offset. The two ice giants share that strange feature. There is something about how they are built, deep inside, that has put their magnetism off-center. We are not sure why. Only the one spacecraft has ever visited Neptune. Voyager 2, in 1989. The same machine that visited Uranus, only this time at the further end of its long journey. It flew past, took its pictures, sniffed the planet's air from a safe distance, and went on, into the deeper dark beyond. It is still out there, billions of kilometers further now, still very slowly leaving our solar system, Nothing else has ever been back to Neptune. Almost everything we know about it comes from that one quiet flyby, plus the long careful watching from telescopes here at home. There is something striking about Neptune's interior, beneath the wild blue clouds and the wild winds, that has been suggested by careful pressure calculations. Deep inside Neptune, in the great hot pressurized middle of the planet, conditions may be just right for carbon, which is present in the planet's mix, to crystallize into something quite remarkable. Diamonds. Small diamonds, perhaps. Diamonds, perhaps, the size of icebergs. They may form in the deep blue dark, miles down in the planet, and then sink slowly through the dense fluid below, settling toward the core. There may be, somewhere in Neptune, a long slow rain of diamonds, falling forever. Nobody has seen it. Nobody will, probably, ever see it. But the chemistry, as we understand it, allows it. It is a soft, strange thing to imagine in the dark. A planet that, deep inside, is quietly raining stones of light. And there is something gentler still about Neptune's captured moon. Triton, going the wrong way round its planet, is slowly losing its orbit. Very slowly. Imperceptibly. But over a few thousand million years, Triton will spiral closer and closer to Neptune. Eventually, perhaps, it will drift inside the Roche limit, where the planet's pull would tear it apart. And when that happens, Triton will not survive as a single body. It will be shattered, like a sugar cube dropped in tea. And the pieces will spread out into a great ring around Neptune. Neptune, the planet with only faint thin rings now, may, in some distant future, have rings that rival Saturn's. It will not happen in our lifetimes. It will not happen in any lifetime that has ever existed on Earth. But Neptune, at some point in its future, may grow beautiful in a way it currently is not. That is one of the kind of thoughts you can carry away from this distant cold world. Neptune's day is short. About 16 hours from one sunrise to the next, although sunrise at Neptune is a faint thing indeed. The planet turns gently, despite its great winds, despite its violent weather. The clouds turn with it. The dark spots that come and go are carried around the planet in great slow loops, lit by a pale sun that, from where they are, looks like one of the brighter stars in their sky. We will not return to Neptune any time soon. The journey is long, and we have not, as a species, decided to take it again. But Neptune is there. It is always there. It is always turning. And the deep blue and the dim distant sun and the wild quiet winds and the captured backwards moon are all just continuing, with no audience, with no need for one. We will leave Neptune now, with its rich blue, its enormous winds, its captured moon. The planet does not mind. The planet is so far from us that, in the time it took for the light of our day to reach it, the day had already become evening on Earth and the planet had not yet noticed. We are passing through. We are about to step beyond the planets entirely. We are about to enter the third zone of the solar system, the wide cold ring where small worlds drift. Sleep. Neptune is too far for our worries. Neptune is too far for almost anything. Chapter 11, The Kuiper Belt. We have, until this point, walked past every planet in our solar system. 8 of them. From Mercury near the heat to Neptune deep in the blue dark. And now, beyond Neptune, the planetary family ends. But the solar system does not. There is, beyond Neptune, a wide and patient region. A great cold ring of small icy worlds, far further out than any of the planets we have visited. It is called the Kuiper Belt, after a quiet astronomer named Gerard Kuiper who, in the middle of the 20th century, suggested that such a region ought to exist. It does. It is enormous. It is the third great zone of our solar system, after the rocky inner planets and the giant outer ones. And it is, by area, by far the largest. The Kuiper belt begins at about 30 times the Earth-Sun distance, where Neptune's orbit lies, and stretches out to about 50 times that distance, and in some sense further still. It is, like the asteroid belt we passed earlier, mostly empty. Like the asteroid belt, it is a region, not a place. But it is much, much larger. The Kuiper belt is more than 20 times wider than the asteroid belt, and probably contains many times more material. Thousands of icy worlds have been found in it. Probably hundreds of thousands more are out there, smaller and dimmer, never yet noticed by our telescopes. If you could be standing somewhere in the middle of the Kuiper belt, in a kind of spacecraft that could just hover there, you would, again, see mostly nothing. The sun would be one bright star, brighter than any other star, but no longer a disk you could pick out without aid. The other stars would be sharp and cold and beautiful. Your own breath, if you could breathe out there, would freeze in a heartbeat. And somewhere, lit by the distant sun, a small icy world would drift past, slowly, dim and grey. Then nothing. Then nothing. Then, a long time later, another. The Kuiper belt is the home of many small worlds you have, perhaps, never heard the names of. There is Eris, which was discovered in 2005 and is almost exactly the same size as Pluto, slightly smaller but slightly heavier. There is Haumea, which is so oddly shaped that it is not round at all but rather like an elongated egg, spinning end over end so fast that it has stretched itself into the shape of a great cold rugby ball. Haumea has 2 small moons and a faint ring of its own. There is Makemake, which is reddish, with bright and dark patches, smaller than Pluto but still substantial. There is Sedna, even further out, on a long lopsided orbit that takes it tens of thousands of years to complete. There is Quaoar, and Orcus, and many others, each one its own small world, each one with its own name from some old myth or distant culture, each one slowly going about its long quiet circle out in the cold. The Kuiper belt is also where short-period comets come from. Now and then, one of the small icy bodies out there is nudged inward by the pull of Neptune or some passing object. It falls slowly toward the sun. When it gets close enough, the warmth begins to vaporize its ice, and it grows a great pale tail, and it becomes one of the bright slow visitors that, every few years, sweeps across our skies and is photographed by everyone with a camera. Many of the comets we see are, in their origin, small icy bodies that left the great cold ring and fell inward for a brief, hot, brilliant visit. They will, mostly, return to the cold. The Kuiper belt is, in a way, the dark warehouse where most of our comets live. There are some places in our solar system that have hardly been touched by anything, hardly changed by anything, for almost the whole age of the universe. The Kuiper belt is one of them. Its worlds are made of the same primordial ice and dust that gathered when our solar system first formed. They have been sitting out there, very cold, very still, for 4,500 million years. They are, in a sense, a museum of how things began. If you wanted to know what the early solar system was made of, before the planets formed, before the sun settled, before the Earth ever rounded into shape, you could do worse than to look at the small icy worlds of the Kuiper belt. They are pieces of the beginning, frozen. A spacecraft has been there. A small craft called New Horizons, which flew past Pluto in 2015, kept going. It had enough fuel and enough patience to visit a second target. In 2019, after years of further flight, it flew past a small Kuiper Belt object that, at that time, was the most distant object any spacecraft had ever visited. It was called Arrokoth. It is shaped like a small frozen snowman, two round lobes stuck together, one slightly larger than the other. It has been sitting out there, exactly as it is, for 4,500 million years. It has not changed. It has not been disturbed. It is one of the most ancient, most unaltered things in our entire solar system. It is, in a sense, a baby photo of our beginnings, preserved in the dark. The pictures of it came back slowly, one careful packet of data at a time, across all those billions of kilometers. They are, even now, some of the strangest photographs ever taken. A small lumpy double world, dim red, lit faintly by a sun so distant it is barely a sun anymore. The Kuiper Belt is not the very edge of the solar system. Beyond it, there is something even larger and even fainter, a great spherical shell of icy bodies called the Oort cloud, which is thought to extend almost a light year out into the dark, almost a quarter of the way to the nearest star. The Oort cloud is so far away and so spread out that it has never been seen directly. It is where the very long comets come from, the ones that take millions of years to return to the Sun. But that is further than we will go tonight. Tonight, the Kuiper Belt is our last region. And in the middle of that region, although it has been quietly demoted from planet to dwarf planet, sits the small world we are here to meet last. There are some things that are only barely worth naming, and yet have names anyway. The small icy bodies of the Kuiper Belt have, between them, a great long list of soft slow titles. Each one was assigned by a small group of astronomers who, having discovered the thing, picked a name from a creation myth somewhere on Earth and gave it to the world. Quaoar is a creator figure from the Tongva people of California. Orcus is a Roman god of the underworld. Sedna is an Inuit goddess of the sea. Makemake is a creator god from the Rapa Nui people of Easter Island. The names come from many corners of human storytelling, gathered into the cold, given to small worlds that nobody will ever visit. It is, in a way, one of the more touching habits of astronomers to take the names of old gods and old spirits and pin them gently to the small things at the edge of the known. The Kuiper Belt is not always a wide flat ring, by the way. It is more like a thick donut, or perhaps a soft cloud, with most of its objects in a band but a great many of them tilted up and down, on inclined orbits, on lopsided orbits, on orbits that almost wander out of the ring entirely. There are scattered disk objects, as they are called, that come close to the inner Kuiper Belt at one part of their orbit and then sail away into the cold beyond. Sedna, the most lonely of them, takes more than 10,000 years to make a single circle, swinging in close, then arcing out to a distance where the Sun is barely a point of light, and then coming back. Some of the small worlds out there have orbits so long, and journeys so far, that human civilization has not lasted as long as one of their years. They are, in a sense, on a different time. They were last in this part of their orbit before any cities existed. They will be in this part again long after every city we have ever built is gone. New Horizons, the spacecraft that visited Pluto and Arrokoth, is still flying. It is, even now, drifting further outward, into the wider Kuiper Belt, taking the occasional careful picture of small icy bodies as it passes near them. It is running on a little nuclear battery that will not last forever. In time it will go silent. But it will keep going. It will, eventually, leave the solar system entirely, joining the voyagers in the long slow drift toward the stars. Each of those spacecraft, having done what we sent them to do, will continue, lifeless, into the dark, for many ages. They carry small messages from us. records, drawings, sounds. They were placed there in the hopes that, perhaps, very far from now, some other curious species might find them. That is a kind thought to take to bed. That we have flung a few small messages into the long dark, in case anyone, anything, is reading. The very edge of our solar system is not the Kuiper belt, but a much further place called the heliopause. It is the point where the sun's wind, that gentle stream of particles we met all the way back at the sun, finally peters out and gives way to the wind of the larger galaxy. Crossing that boundary is, in a sense, leaving our system entirely. The Voyagers crossed it years ago. They are now, technically, in interstellar space, though that does not feel quite as dramatic as it sounds. The change is slow. The dark is the same. The cold is the same. But the wind they sail in now is no longer the breath of our own Sunday. It is the breath of everything else. It is hard to picture how empty the Kuiper belt is, in the same way it was hard to picture the asteroid belt. Most of it is just space. Most of it is just dark. Now and then, lit faintly by a sun that is almost too small to feel, a small icy world drifts past, slow and patient, on its long circle that takes hundreds of years. Some of these worlds have moons. Some of them have small rings. All of them are made mostly of frozen water and frozen methane and frozen nitrogen, packed together with ancient dust. They have been doing what they're doing for as long as anything has been doing anything. The Kuiper belt is the long quiet outer shelf of the solar system. The third zone. The cold ring. The slow drift. Sleep. The cold belt drifts on. It does not care that you are tired. Chapter 12, or Pluto. We have reached the last world of the journey. The small one. The cold one. The one that, for a long time, was called the ninth planet, and that is now called something gentler, a dwarf planet, but that, in the hearts of most people who grew up with it, is still simply Pluto. Pluto is small. Smaller than our own moon. About 2/3 the size of it. It is far. It is, on average, about 39 times the Earth-Sun distance, although its orbit is so lopsided that sometimes it is closer to the Sun than Neptune is, and sometimes much further. It takes Pluto about 248 Earth years to make one trip around the Sun. There are babies being born today who will not live to see Pluto return to the spot in the sky where it was when they were born. The planet, if we may still call it a planet in some affectionate way, finishes its year very slowly indeed. For most of the last century, all we had of Pluto was a small dim dot. It was discovered in 1930 by a young American astronomer named Clyde Tombaugh, who was patiently comparing photographs of the same patch of sky taken on different nights to look for anything that had moved. He found one small dot that had moved. It was Pluto. For all the decades after that, even our largest telescopes could only show Pluto as a faint blurry smudge. We did not know what it looked like, really. We did not know what it was made of, really. We could see that it had at least one moon, a large one called Charon, which is so big compared to Pluto that the two of them orbit a point in space between them, more like a double world than a planet with a moon. We could see that Pluto had a thin atmosphere. We could see that it was reddish. That was, more or less, all. And then, in 2015, a small spacecraft called New Horizons reached Pluto. It had been flying for nearly 10 years. It had been launched when Pluto was still officially a planet. By the time it arrived, Pluto had been demoted to a dwarf planet. The spacecraft did not care. It flew past the small world at high speed, took thousands of photographs in a few quick hours, gathered all the data it could, and continued on into the further Kuiper belt. Those photographs, when they came back, very slowly, packet by packet, across the billions of kilometers, showed us something nobody had quite expected. Pluto was beautiful. Pluto was a real world, with mountains, and plains, and ice, and a strange pale heart-shaped feature on its surface, a great pale region in the shape of a heart, with smooth nitrogen ice on one side and rugged frozen terrain on the other. The heart, in fact, is named Tombaugh Regio, after the man who first found Pluto, all those decades ago. There it Saturday. A pale heart on a small far world. A face for the planet that until then had been only a dot. Inside that heart, there is a great smooth basin of nitrogen ice. It is called Sputnik Planitia, after the first satellite ever launched. It is roughly the size of Texas. It has no craters, which means it is geologically young, which means something is still working on Pluto, even now, to repave it. The nitrogen ice slowly convects, like a very cold version of soup simmering on a stove, with great slow cells of ice rising and falling, rearranging the surface, smoothing it. Pluto, this small far world, is still alive in its own way. It is not a dead frozen lump. It is something quieter, slower, but still moving. Pluto has mountains too. Tall ones. Made of water ice, which at Pluto's temperatures is hard as stone. They rise in pale white ridges along the edges of the heart. They look very much like mountains on Earth, only built of a different material. There are dark patches near the equator, which may be hydrocarbons settled out of the thin atmosphere. There are pits, and ridges, and strange terrains nobody has fully explained. Pluto is, in short, much more complicated than anyone expected. A small world, far from the sun, doing many things at once, in the cold. Pluto has 5 moons. The largest is Charon, which is so big that, as already said, the two of them swing together around a point in the empty space between them. From Pluto, Charon hangs huge and grey in the sky and does not move from its position in that sky, because the two worlds are tidally locked, each one always showing the same face to the other. If you stood on Pluto and looked up, Charon would be there, always in the same spot, slowly going through its phases as Pluto turned beneath it. The smaller moons are tiny and irregular, named after underworld figures from mythology. Nyx, Hydra, Kerberos, Styx. A small dim family, in the long cold dark. The sun on Pluto is small. Very small. From Pluto, the sun looks like just another star, brighter than the rest perhaps, but nothing like a sun. It would give about 1,000th the light it gives here. The light at midday on Pluto is roughly the light you have at home, just outside, in the few minutes after sunset on a clear evening. A kind of long perpetual dusk. The shadows on Pluto are long and soft. The whole world is held in that quiet, not quite dark, all of the time. And yet, Pluto has an atmosphere. A very thin one, made of nitrogen, with a little methane and carbon monoxide. As Pluto travels through its long oval orbit, when it is closer to the Sun, more of the surface ice warms slightly and rises into a thicker atmosphere. When it is further from the Sun, the atmosphere freezes back onto the ground. Pluto breathes, slowly, over centuries. It exhales when it gets close to the Sun. It inhales when it drifts back out. It is a long, slow respiration that you cannot watch in any one human life, but it is real, and it is happening. If you stood on Pluto, in whatever suit could let you survive there, you would see a pale, very cold landscape. White ice plains. Dark red hills. Mountains of frozen water. The huge grey face of Charon hanging in the sky. The sun, a bright but small star, casting long soft shadows across the ground. There would be no wind to speak of. There would be no sound. There would only be the long cold quiet, and the slow turning of the small world beneath your feet. For all that it is dim and far and small, Pluto has captured something tender in human hearts. People grew up calling it a planet. People wept, a little, when it was demoted. Children all over the world drew pictures of Pluto with smiling faces when New Horizons sent back the heart. There is something about Pluto. Something to do with being last, and being small, and being so far from the warmth, and still being, somehow, a real place, with mountains and ice and weather. A small world holding on, at the very edge of where worlds go. There is something even stranger going on inside Pluto, that we are still trying to understand. The way the heart-shaped feature, and especially Sputnik Planitia, sits exactly opposite Pluto's largest moon Charon, in the sky, is hard to explain by chance. Some scientists think there may be, under the great smooth ice of Sputnik Planitia, an ocean. A real liquid ocean. Of salty water mixed with ammonia. Kept warm enough to stay liquid by the slow leftover heat of Pluto's old radioactive core, and trapped beneath a thick lid of ice. If there is such an ocean, it would be a quieter cousin of the oceans we have suggested for Europa and Enceladus and Ganymede. Even out here, at the dim edge of things, water may be hiding. Even out here, gentle warm dark places may be tucked under the ice. The atmosphere of Pluto is thin and surprising. It is mostly nitrogen, with a little methane, and it forms a faint haze that surrounds the small world, layer after layer, fading into space. When New Horizons flew past Pluto and turned its cameras back, the sun shining through Pluto's edge revealed the haze as a beautiful pale ring around the planet, glowing faintly blue. Pluto, the cold little world at the edge, has a blue halo. A soft thin blue sky, if you stood on its surface, hugging close to the horizon. One more small lovely thing nobody knew until we went to look. Pluto's day, the time from one sunrise to the next, is 6.5 Earth days long. Slow. Pluto turns gently. Its companion Charon turns with it, in the same slow rhythm, the two of them always showing each other the same face, the way a dance partner you have grown comfortable with would always be facing you, no matter how slowly the music played. From half of Pluto, Charon is always in the sky, never moving. From the other half of Pluto, Charon is never seen at all. The two worlds are quietly bound. Whatever centuries pass, they will be in that same arrangement, looking at each other, going round the sun together. When New Horizons left Pluto behind in 2015, it took one last picture, looking back at the small world with the sun behind it. The picture showed Pluto as a thin-lit crescent, with the haze of its atmosphere glowing in pale blue around its dark side, like a small lit doorway in a long dark hall. It is one of the more beautiful pictures ever taken in our solar system. A small far world, lit only from behind, glowing softly against the deep dark of the outer solar system. A goodbye photo of a world that, for almost a century, we had not really seen, and that, having shown us its face for a few brief hours, would go back to its long quiet circle. This is the furthest we will travel tonight. There is more solar system beyond. There is the rest of the Kuiper belt. There is the great wide spherical shell of the Oort cloud, where the long comets sleep. There is the boundary where the sun's wind finally fails, far out, where our system gives way to the wide quiet space between the stars. But we will not go there tonight. Pluto is far enough. Pluto is the lit lamp at the end of the long porch. We will sit with it for a moment before we turn around. Sleep. Pluto is patient. Pluto has waited for thousands of millions of years. It can wait another night. Closing. And now, slowly, we turn back. Not all at once. There is no need to hurry. The sun, somewhere in front of us now, is still a small bright star, no warmer than it was. But the journey is gentling its way back toward home. The long cold of Pluto is fading. The blue darks of Neptune and Uranus are fading. The pale rings of Saturn, the great striped giant of Jupiter, the slow stones of the asteroid belt, the small red Mars, the soft blue Earth, the clouded Venus, the scarred Mercury, all of them are passing back, in reverse order, in the gentlest possible drift. You are back in your bed. The room is the same room. The blanket is the same blanket. The breath, your breath, is still happening on its own, the way the planets are still turning on their own, the way the sun is still shining on its own. Nothing has been required of you. The solar system is going on without you. It always was. And the sun is at the center of all of it, holding the whole thing together with a quiet, patient pull, throwing light and warmth outward, 8 minutes to reach you, hours and hours more to reach the further worlds. You are inside that warm reach. You are part of it. There is no quiz. There is no test. You do not need to remember any of this. The names were pleasant to say in the dark, and that was enough. Rest now, in the warm small corner of a very large house. Tomorrow will come, slowly, because the earth is turning, and the sun is rising on somebody else first. By the time it reaches you, you will be ready. Sleep. The solar system is fine.